Hi, my name is Tim Griffis. I'm in the Department of Soil, Water, and Climate. I'm a professor of biometeorology, and we're talking today about our project on the mesocosm facility, which is research that's been funded by the Minnesota Corn Growers Association. And what we have done is each mesocosm is filled with about 9,000 pounds of agricultural soil that was in a long-term corn-soybean rotation from Kenyon County. And what we are doing is simulating future climate, really looking specifically at how changes in future precipitation are likely to impact farming in Minnesota. What we are doing is using model simulations from the best climate models that are out there, and we're using an ensemble of those best models and looking at what they predict future climate will be in 2050. And we're using that as a way of adjusting environmental conditions and growing crops basically in the year 2050. A couple things that are changing dramatically across the landscape today. That is the timing and magnitude and extremes that we see in precipitation. That's going to have a potentially dramatic impact on how nitrogen is used in these systems. The other thing that's happening is that we're seeing a rise in temperature, which is affecting productivity. So we suspect, or we hypothesize, that warmer temperatures are going to result in less carbon dioxide uptake for this region. All those things can affect future crop yields and can affect the sort of future amount of nitrogen that we use when we're growing these types of crops. Some of the research that we're performing here, we're hoping will allow us to be more successful in sustainably growing corn crops in Minnesota. So for example, type of fertilizer to use, when is the best time to apply that fertilizer, how can we increase the nitrogen use efficiency of these systems. Ultimately, the end goal of our research is to help find more sustainable ways of growing corn crops in Minnesota. Working with designer microbes that are efficient at fixing nitrogen for the crops, we are aiming to lower the overall synthetic nitrogen use and at the same time improving nitrogen use efficiency in these systems. We really want to limit the amount of synthetic nitrogen that is entering our waterways and entering our atmosphere. We appreciate the support from the Minnesota Corn Growers Association. It's allowing us to study how we can reduce synthetic nitrogen use in these systems and really lower the reactive nitrogen losses to waterways and the air in Minnesota.